Welcome to Spaceverse, your portal to cosmic adventures. The latest weather forecast doesn't come from Dublin, London, or New York. It comes from deep space, where a lonely world drifts without a sun and glows with auroras more dazzling than anything Earth has ever seen. This strange, solitary world is called SIMP-0136, and it's rewriting what we thought we knew about planetary weather. Roughly 200 million years old and located about 20 light-years away in the constellation Pisces, this object sits in the twilight zone between planet and star. Astronomers call it a brown dwarf, sometimes nicknamed a failed star. That name might sound a bit harsh, but it tells us something fascinating about how this cosmic object came to be. Like stars, brown dwarfs form when vast clouds of gas collapse under their own gravity. But in SIMP-0136's case, the process didn't go far enough. It never accumulated enough mass to ignite hydrogen fusion in its core, the process that powers stars like our sun. So it sits in the middle ground. Not quite a planet, not quite a star, but something in between, a glowing, drifting ember in the darkness of space. What makes SIMP-0136 even more unusual is that it doesn't orbit a star at all. It's what astronomers call a rogue world, an object cast adrift through the galaxy, traveling alone without a parent sun. It spins incredibly fast, completing one full rotation every 2.5 hours, which means that days on this world flash by in what would be less than a single class period on Earth. Now, thanks to the incredible sensitivity of the James Webb Space Telescope, scientists have delivered something remarkable: the most detailed weather report ever for this kind of world. For the first time, researchers have tracked how a brown dwarf's atmosphere changes over time, monitoring shifts in temperature, chemistry, and cloud cover as SIMP-0136 spins through its dark journey across space. This breakthrough study, published on September 26 in the journal Astronomy and Astrophysics, marks the first time astronomers have directly measured how the atmosphere of a brown dwarf changes in real time. It's not just another observation, it's a key step in understanding the dynamic, ever-changing environments of worlds beyond our solar system. These are some of the most precise measurements of the atmosphere of any extrasolar object to date, said Evert Naeskin of Trinity College Dublin, who led the study. And it's the first time that changes in the atmospheric properties have been directly measured. His colleague Joanna Voss, also from Trinity College Dublin, added, "Understanding these weather processes will be crucial as we continue to discover and characterize exoworlds in the future." So, what did JWST actually find? The telescope's instruments are so sensitive that they can detect minute changes in brightness, tiny flickers in the light coming from SIMP-0136 as it rotates. Astronomers use these faint variations to essentially map the planet's atmosphere, layer by layer. For years, scientists suspected that the flickering light was caused by patchy clouds drifting across the surface, much like how Jupiter's bands and storms reflect sunlight differently. But JWST revealed a twist. The clouds on SIMP-0136, made of sand like grains of hot silicates, are surprisingly stable. They're not shifting or churning as much as expected. Instead, the real drama seems to be happening higher up, in the planet's upper atmosphere. There, astronomers found a layer of air nearly 570 degrees Fahrenheit or 300 degrees Celsius warmer than their models predicted. That's a huge discrepancy, and it immediately raised the question, what's heating the air so much? The answer, it turns out, is auroras, and not the mild, graceful kind we see on Earth. Here on our planet, auroras, the northern and southern lights, occur when charged particles from the solar wind collide with atoms in our atmosphere, guided by Earth's magnetic field. The result is a breathtaking light show of greens, purples, and reds dancing across the polar skies. But SIMP-0136's auroras are on a completely different scale. Because this rogue world has a much stronger magnetic field than Earth, the charged particles slamming into its atmosphere do so with enormous energy. The collisions don't just create light, they heat the atmosphere itself, pumping energy into those upper layers and causing that unexpected temperature spike. In other words, SIMP-0136's skies are constantly being bombarded by cosmic storms of light and heat, creating a display that would make Earth's auroras look like faint ripples by comparison. And that's not the only surprise. JWST also detected tiny temperature swings, less than 40 degrees Fahrenheit or 5 degrees Celsius, deeper in the atmosphere. Those subtle variations might not sound like much, but on a planetary scale, they could signal something huge. The presence of giant storm systems, possibly similar to Jupiter's Great Red Spot, moving slowly across the planet's surface as it spins. Imagine a world lit by blazing auroras, filled with swirling sand clouds, and dotted with massive, colorful storms, all floating freely through the galaxy without the warmth of a nearby sun. It's a hauntingly beautiful image, and it gives scientists an entirely new way to study the physics of alien worlds. What makes brown dwarfs like SIMP-0136 so valuable to astronomers is that, since they don't orbit bright stars, they aren't overwhelmed by the glare that makes studying distant exoplanets so difficult. The light we see from them comes directly from the object itself, letting researchers analyze its spectrum and brightness with incredible precision. That means brown dwarfs act as stand-ins or laboratories for understanding the atmospheres of true exoplanets, especially gas giants orbiting other stars. By studying these failed stars, astronomers can refine their models of how clouds, winds, and auroras behave under different conditions. The new findings are just the beginning. As the James Webb Space Telescope continues its mission, astronomers plan to apply these same techniques to actual exoplanets, worlds that do orbit distant suns. And they're not stopping there. Future observatories, such as the extremely large telescope in Chile and NASA's Habitable Worlds Observatory, will have the capability to perform similar observations on even fainter, smaller worlds. That could include rocky, Earth-like exoplanets where understanding weather and climate could help identify conditions suitable for life. By comparing what they learned from brown dwarfs like SIMP-0136 with data from true exoplanets, scientists hope to build a complete picture of atmospheric evolution across the galaxy, from massive gas giants to smaller, possibly habitable worlds. And that's the exciting part. Even though SIMP-0136 is a lonely wanderer, cut off from the light of any sun, its strange and vivid weather patterns are helping us learn how planets everywhere breathe, churn, and glow. Each rotation of this brown dwarf, every 2.5 hours, brings new flickers and changes, tiny signals that JWST can now detect with astonishing clarity. Those changes tell stories of heat, magnetism, and chemistry, stories that may someday help us understand not just distant exoplanets, but even our own world's place among them. Think about it. A planetless object, glowing faintly in the cold darkness of space, is now giving us the first detailed weather forecast ever made for a world beyond the solar system. It's an achievement that blurs the line between astronomy and meteorology and opens a new window into the lives of alien worlds. As the study's authors put it, understanding these weather processes will be crucial as we continue to discover and characterize exoworlds in the future. In the coming years, telescopes like JWST will continue to push the boundaries of what's possible. We'll likely see even more detailed observations of brown dwarfs, rogue planets, and exoplanets orbiting distant suns, perhaps even glimpses of rain made of molten glass, clouds of metal, or skies lit by storms of plasma. SIMP-0136 may be a failed star, but in a way it's shining brighter than ever, illuminating the path toward understanding the weather of the cosmos itself. And as we keep gazing outward, one thing becomes clear. Even in the darkest corners of space, there's always something stirring, winds blowing, clouds shifting, and auroras dancing in colors we've yet to imagine. If you enjoyed diving into the mysteries of SIMP-0136 and the incredible work of the James Webb Space Telescope, don't forget to leave a like. It really helps Spaceverse grow. Share your thoughts in the comments below. What kind of weather do you think might exist on other rogue worlds drifting through the galaxy? And if you haven't already, subscribe to Spaceverse for more deep dives into cosmic discoveries, interstellar mysteries, and the science shaping our view of the universe. Until next time, keep your eyes on the stars, because out there, even in the coldest voids, the universe is always alive with wonder.